Welcome to the series of lecture in computer architecture. Today we will continue our discussion with respect to the building the data path. So in the previous two classes we have building the data path for instruction fetch and then as well as R type instructions. We will continue our discussion further, right? Right. Now we will look on to the load store instructions. So we know that two important memory reference instruction in MIPS is load store, that is load word and store word, right? Now first we need to read the operands, register operands. Now we need to calculate the address using the 16-bit offset, okay? Because in load word and store word we are having an offset value that is present directly in the instruction. So that is represented as 16 bits. Now that 16-bit offset should be converted into 32-bit. Okay, now for that purpose only we are using this sign extension unit. So the sign extension unit is another unit, functional unit, which is added to the data path for converting the 16-bit offset to 32-bit. How it is converted? So whatever the MSB value that is present in the 16-bit data, that will be replicated in the higher order bits. What is that higher order bits? The remaining 16 bits. So there is 16 remaining higher order bits will be replicated whatever the value that is available in the MSB of this 16-bit, original 16-bit. Okay. For example, if the MSB value is 1 in the 16-bit offset, that 1 will be replicated 16 times in the higher order bits. So you will be getting 16 ones added so that it becomes totally 32 bits, right? Now what is this load word? The load word instruction will be reading the content from the memory location from the data memory, okay, and it is updating the register. So from memory to the register. Store word means from the register, the value is getting stored to the data memory, right? So here we are going to employ another functional unit, that is data memory. So here we are going to have two important control signal, memory read and memory write. So when this will be initiated, memory read will be initiated whenever we are going to read the content from the memory. That is for the load word, okay, from memory to register. Memory write control signal will be initiated whenever a new value is going to be stored from the register to the memory. So these two are the important control signal for the activating the data memory for a particular point of operation, right? So this is address port to fetch to read or write into the specific location. This is write data. That write data should be initiated whenever we are going to write the data to the memory location, okay, and then read port for reading the content. Okay, so this is the data memory symbol and this is sign extension unit symbol. Right, now we will go to the data path. Okay, so you know that the instruction format is I format because the offset is available within the instruction. So opcode, RS, RT, and then offset, 16-bit offset, right? So this is the instruction format. Right, now these RS, one of the source register that is given to the register. This RT is going to be the register which holds the corresponding base register, base value of the memory. So we are going to read these two values to the registers, okay, and then this immediate 16-bit offset, if you see, it is given to the input of the sign extension unit where it is the sign is extended to the higher order bits and it is converted into 32-bit. That is given as the one input of the ALU. Now whatever the corresponding RT value, okay, RT value, the base address, that is the value that is available in RT, that is added with this offset to get the exact memory location in the data memory. So the exact location is referenced and where the corresponding value available in that particular memory is taken or read from the corresponding data memory and it is getting stored into the register. So this is the exact path with which the data path is functional. These are all the functional units which is getting initiated during the execution of this load word instruction. And if you see with respect to the instruction fetch, from the instruction fetch, so we are fetching the instruction and the 16-bit is converted into 32-bit using sign extension unit, and this RS and RT is fed into the register and one input of the ALU, okay, that where the base address is available in a particular register is added with the offset. Then it is located into the data memory. From the data memory we are reading the exact value and we are getting stored into the register. So this is the operation with respect to the load word instruction. Now we will see the entire load word instruction including instruction fetch. So the instruction is fetched and automatically at the same time it is incremented by 4 because this is a simple load word instruction and there is no branch instruction involved. So the PC will be incremented by 4 using this adder and the PC will be incremented here. Okay, right? Now the 32-bit instruction is fetched where the 16-bit offset is fed to the sign exchange unit and the register ports are accessed with respect to RS and RT, right? So the lower portion shows the execution path for the load word instruction. Right, now we will be going for the store word instruction. What is the store word instruction? So it is opposite of the load word instruction. We are going to store the content of the register to the memory. Okay, so the opcode, RS, RT, offset and immediate, these instruction format is same that of load word instruction, but only one thing is different is we are going to store the corresponding that is value to the register. Okay, from the register to the data memory, right? From the register to the data memory, right? So that is given here, right? So the 16-bit offset is again converted into 32-bit using sign extension unit, right? And it is given as one input to the ALU and the corresponding RD2. RD2 is the RT, right? That field is given to the corresponding data memory. So where we need to write, okay, where we need to write, okay, right? And then the base address from the RT, right? RT is calculated, that is base address plus this offset is calculated, addition is performed and we are going to indexing into the data memory. Okay, this from the register, okay, which holds the value, that is RS, that RS register holds the original value data that is going to be stored into the data memory. Okay, so this RS is going to be, the RS value is going to be read directly into the write data port. So if you see, this is very important. Okay, right? So that is the flow for store word instruction. So this is this from the instruction. Okay, from the instruction fetch, 16-bit is indexed, given to the sign extension unit and it is converted into 32-bit. Okay, the RT field is given to ALU. The RT field, okay, the RT field is means that base address. Base address is told by RT and it is added with the offset using the ALU and we are going to index into the memory location. This RD2 is going to be having the content of the source register. That source register value is directly written into the write port of the data memory, right? So this is the exact data path functionality. Okay, which particular functional units are active during the course of execution of software, that is store word instruction. So PC is equal to PC plus 4. This adder is involved and because it is a simple store word instruction, this PC is equal to PC plus 4 is directly taken. Okay, so this is the green color path which is for instruction fetch. Next, the 32-bit instruction is fetched and the offset 16-bit is given to the sign extension unit for converting into 32-bit. And this RT field is directly taken, that is base address value is taken and given to the one input of ALU, and this base address will be added with the offset to get the exact memory reference, memory location that is highlighted in this light red color. Okay, this RD2 value, okay, that is value available in the source register is directly taken and written into the write data port of the data memory. So this store word from register to the memory. Okay, so in the next subsequent lectures we will learn further instruction of the MIPS implementation.